So this figure depicts the general classification of the supervised machine learning algorithm. You can see as I've already explained, you can see the training data here, and then we're implementing the machine learning program here, and then the three parts are here actually. So testing data, then classification rules, and then the output basically predicted classification. So this is the supervised algorithms, the generalized classification architecture here. I have put here so for better understanding of the listeners, audiences. Now there are some issues of supervised learning algorithms as well. So that's actually I'm gonna explain all these things right now. The learning from the past experiences is an attribute of humans, while the computers don't have this ability. In supervised or inductive machine learning, our main goal is to learn a target function that can be used to predict the values of a class. The process of applying supervised ML is to a real-world problem is described here in this figure. You can see this is the training data here that I put here, the labels, then test data. So there are two types of data will be there actually, train data and test data. And also, as you know, as I've already explained, in supervised ML, supervised machine learning algorithm, it only deals with labeled data sets, labeled data or information. So here you can see it from training data. This is a supervised learning model. Then it comes with this ML algorithm. Then prediction model here. That's the output, and then we are basically expected levels. That is the output coming out. Now the issues are here in supervised learning. The first step is dealing with dataset, right? In order to perform a better training on dataset, an appropriate expert could suggest better selection of features. If concerned expert is not enriched, then the other approach is brute force, which means measuring everything available in the hope that the right informative relevant features can be isolated. However, a dataset collected by the brute force method isn't directly suitable for induction. Ultimately, in most cases, it actually contains a noise, that is a noise and missing feature values, and therefore requires significant preprocessing. In the next step, the data preparation and the data preprocessing is the key function of researcher in supervised ML or SML, that supervised machine learning. A number of techniques have been introduced by different researchers or research groups around the globe to deal with the missing data issue. A research group, Hodge and Austin, have conducted a survey contemporary techniques for outlier noise detection. Another group, Karanjit and Suchitra, have also discussed different outlier detection methods which are being used in different machine learning. Asia has done comparison on 6 different outlier detection methods by performing experiment on benchmark datasets and a synthetic astronomical domain. So here I've already put some light on this supervised machine learning model here and its issues as well. Now let's talk about the algorithm selection. The selection of the algorithm for achieving good results is an important step. The algorithm evaluation is mostly judged by prediction accuracy. The classifier's algorithm evaluation is most often based on prediction accuracy, and it can be measured by given a below formula by the given formula that I'm going to I'm just saying this because I've been mentioned here. So it will be accuracy equals number of correct classification divided by total number of test cases. So there are a number of methods which are being used by different researchers to calculate classifiers accuracy. Some researchers splits the training set or the training data in such a way that 2/3 are retained for training and the other third for estimating performance. Cross validation or CV or rotation estimation is another approach. Well, CV provides a way to make a better use of the available sample. In careful cross validation scheme, we divide the learning sample into k disjoint subsets of the same side, that is ls equals ls1 1 intersection ls2, union ls2 union lsk, so up to k. A model is then inferred by the learning algorithm from each sample ls1 ls equals 1 to k, and its performance is determined on the held out sample lsi. So I is basically the is a number that is basically varying from 1 to k. Well, so final performance is computed as the average performance over all these models. Notice that when k is equal to the number of objects in the learning sample, this method is called leave one out. So this is the method that is named as leave one out, leave -1 -out. Typically, smaller values of k, 10 or 20 are however preferred over for computational reasons, because it will definitely take some leisure computational resources or lesser computational time as well. So the comparison between supervised ML methods can be done to perform statistical comparisons of the accuracies of trained classifiers on specific datasets. For doing this, we can run two different learning algorithms on samples of training set of size n, that's capital N, estimate the difference in accuracy for each pair of classifiers on a large test set. For classification of data, a good number of techniques have been developed by researchers, such as logical statistics based techniques. Well, now I will precisely discuss the most important supervised machine learning techniques, starting with logical techniques here. Now which are logic-based algorithms? Now logic-based algorithm, basically I'm gonna explain two logic-based algorithms, the learning methods, that is decision trees and rule-based classifiers. So decision tree is actually one type of algorithm. Machine learning algorithm is a very important thing. So in decision tree, I will explain entropy. I will explain the information gain, that is the lesser the entropy, the more is the information gain, and the vice versa. So in machine learning domain, the decision tree induction is currently one of the most important supervised learning algorithms in artificial intelligence AI field. Quinlan has contributed to his ID3 and C4.5 algorithms. C4.5 is one of the most popular and the efficient method in decision tree based approach. Here a C4.5 algorithm creates a tree model by using values of only one attribute at a time. According to authors, the decision tree induction, which was initially designed to solve classification problems, has been extended to deal with single or multidimensional regression. So the major benefits of decision trees or decision tree algorithm or machine learning algorithm are number one, produce intensive results, and number two, easy to understand, and number three, holds well organized knowledge structure. Now DT or decision trees are trees that classify instances by sorting them based on feature values, where each node in a decision tree represents a feature in an instance to be classified, and each branch represents a value that the node can assume. So there are three nodes actually in the decision tree. One is root node, another is branch node, and there is a leaf node. So root node is basically with the highest information gain, then comes branch node, and the last one is a leaf node. So this is decision tree machine learning algorithm. Now let's show something on the screen, on my desktop screen. So let's switch to the other document that I have put here. So let's go there.